In this video, we're going to look at touching circles and how to investigate whether circles touch internally or externally. So here we have equations of two circles, and what we will need to do first, before we conduct our investigation, is extract the information from the equations we're being provided. So in this scenario, both circles are given in the second general equation of the circle format. So what I'm going to do is to extract that information is I'm going to let what we have here, which is x squared plus y squared minus 2x, and I'm going to put in a 0y, because there is no y's, minus 15, and all of that equals the second general equation, which is x squared plus y squared plus 2gx plus 2fy plus c. And what we have then is we can see that in this scenario, x squared is equal to x squared, y squared is equal to y squared. So I can see that those are equal. What I can then see is that minus 2x is the same as having 2gx. 0y is the same as 2fy. And then finally, our c, our plus c, is the same as having minus 15 on this side. So I'm going to let those equal each other and see what we can extract from it. So we have minus 2x is equal to 2gx. So if I divide both sides by x here, I'm going to get minus 2 is equal to 2g. If I divide both sides by 2, I get g is equal to minus 1. So there's one piece that I'm going to use later on. Next, I'm going to look at the y's. So I have in our scenario here 0y is equal to 2fy. So if I divide both sides by y, what I'm left with 0 is equal to 2f. If I divide both sides by 2, what I'm left with is f is equal to 0. So here's a second piece of the puzzle that I'm going to need. And then finally, what I will have is c is equal to minus 15, which is nice and straightforward. No changes to be made here. So from this then, what I can actually get out is I can get out my center. So my center is going to be given by minus g minus f. So if I sub in minus g, so g is already minus 1. So if I sub in a minus 1, I'm going to get plus 1. And then I'm going to have f is 0. Like that. So my center for my first circle is 1, 0. My radius then is going to be given by a formula. And that formula is the square root of g squared plus f squared minus c. So if I fill into that formula, what I'm going to get is minus 1 plus 0 squared minus 15. Now we're going to be careful here because I have minus 1 squared, which is going to be 1, plus 0 squared minus 15 is going to be plus 15, is equal to then the square root of 16, which is equal to 4. So we get a nice value for our radius there. So we've got our center and our radius. Now we do the same thing for the second one, but what I'm going to do this time to speed it up, I'm just going to write down the center, and I'm finding that using the same technique. The center is going to be 7, 8 in this case, and the radius in this scenario, the radius here is going to be 6, using the same formula as above. Now if I sketch those two circles out using the information that I got up here, the center of the first circle, C1, was 1, 0. The center of the second circle was 7, 8. And the radius of that first one, or the second circle here, is going to be 6. The radius of our first circle was going to be 4. So this is what we have here in this scenario. So we've got our two radii and our two centers, and what they're asking us to show is whether they touch externally or internally. Now we can see from this diagram that they touch externally, but how do we prove that? Well, what I can see is that I have two centres that are a distance apart. I'm going to call that distance D, and I'm going to mark that in. So I'm going to just put a line through the centre there like that. I'm going to mark out this distance from here to here, and I'm going to call that D. Right, so there's the distance D. But what I can see is that the distance D is the same thing. This distance D is the exact same thing as if I walked along the pink, which is the first radius, so radius number 1, and then the second radius, which is radius number 2. So if I was able to find out what the distance between those two centres are, it should equal, if they are touching externally exactly, they should be equal to the distance and the sum of the two radii. So let's take a look at that. How would I find the distance between the two centres? Well, it's the distance between the 2 points, which is given by the formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. So what I'm going to do is label my points x1, y1, x2, y2, and I'm going to sub in to that formula there then. So what I have is x2 in this scenario is 7. So 7 take away x1, which is 1, square that, plus y2, which is going to be 8. So y2, which is going to be 8, minus y1, which is 0, square that. So then what I have here is I have 7 minus 1, which is 6 squared, plus 8 minus 0 is 8 squared. So that's what our distance is going to be. If I do that out, then I'm going to have the square root of 36 plus 64. And if I do that out, I'm going to have the distance is equal to the square root of 100, which is going to be 10. Now, is that the same as saying the radius 1 plus radius 2? Well, let's see. So I've got 10. Is that the same thing as saying radius 1, which was 4? So is that the same as saying 4 plus radius 2, which we said had a value of 6? So 4 plus 6 is 10. 10 is equal to 10, therefore they touch externally.